We're now starting section 2.3 day 1. We skipped over 2.2, but 2.3 day 1 is going to be concerned with end behavior of polynomials. Now, we've talked about polynomials in 2.1, what makes a polynomial and what doesn't, so we're going to kind of assume that knowledge right now and take a look at the 4 different cases to what there are for different polynomials and their end behavior. So one thing that you'll notice here is we've got odd, even, positive, negative. That has to do with the odd has to do with the highest degree of the polynomial. So odd degree polynomials would be like x to the third, x to the fifth. Even degree polynomials, maybe something like x squared. And so we're looking at those types of things, assuming that you know what a polynomial is and how it works just a little bit. So the end behavior for a polynomial has to do with what's happening on the outside of these graphs. So I'm just going to draw these arrows in to emphasize that it's what's happening on the left and the right end of this graph. It's not in the middle. We're not concerned about the middle for talks about end behavior. So when we have odd functions, notice that the two ends on the graphs are going the opposite directions. That will always happen for odd polynomials. The only difference is that for positive, the first one is going to go up as we go to the right. The left side is going to go down. That's the positive version, positive leading coefficient, whereas negative leading coefficient just flips it over the x-axis and makes those go the opposite ways, left and up, down and right. For evens, notice that they go the same direction on both sides. So when it's even and the coefficient is positive, we're going up both directions. And when it is odd, when it's even and a negative leading coefficient, we're going down in both directions. What we're going to do is get used to using the limit notation for describing this end behavior, and so on this next page I have it laid out as a way for us to just remember and to organize this information. So we had odd degree positive leading coefficient. If you remember from that last page, that was something like this, where it's going up to the right, down to the left. Now in each one of these notations, you'll notice that I've left the x and the equal part blank on every one of these. What we're going to do is we're going to have a left and a right for every single one. If I'm talking about the left-hand side, I'm going to say the limit as x approaches negative infinity. That's going to be the left-hand side. The right-hand side is going to be the limit as x approaches infinity. You're going to have that for every one of them. So I'm just going to go through here and insert infinity and negative infinity for every one of these, because that part never changes. Now I'm going to go through each case and see what happens as we go to the left or to the right. So x approaching negative infinity means to the left. And so on this graph, as I go to the left, I'm going down. Since I'm going down, I'm going to label this as negative infinity. On the opposite side, going to the right, this one's going up, and so I'll label that as positive infinity. Next was the odd degree with a negative leading coefficient. It just basically flips this graph, and so it's going to have something that looks like this. As we go to the left forever, as x approaches negative infinity, this graph is going up. That is a positive infinity. As this one is going to the right, graph is going down. That is negative infinity. Over here with even degrees, we talked about even degrees basically go the same direction. So my graph on the last page looked kind of like this maybe, or something similar to that. That's an even degree. Both sides are going up, so the left and the right, meaning that we're going to put a positive infinity in both of those spots. Finally, the last possible case is maybe when we flip that one over and we're going down in both directions, so left or right, both of them are heading down, so that's going to be a negative infinity out here. So it can get kind of confusing if you look at it all at once, but just remember that we're doing a left and a right side for each and every one of these, and you just have to decide if the end is going up or if it's going down. That part goes out after the equal sign, and those are kind of the basics of end behavior and using that notation.